Walk you through the setup and the solving part of the quadratic story problems. Find 3 consecutive odd integers. Okay, so already we're going to be looking for 3 odd integers like 13, 15, 17, or 21, 23, 25. We need 3 consecutive odd integers and we don't know what they are. So the first thing we want to do is let's just call the first odd integer x. And once you establish that we're calling the first odd integer x, then the next odd integer, well, it's just 2 bigger than it. So then the next odd integer is x plus 2, and the next odd integer is x plus 4. Okay, so now we've established that we have variable expressions for the 3 consecutive odd integers. Now let's read the sentence. We're going to find these such that the product, which means multiplication, of the first 2. Okay, the product of the first 2 is, meaning equals, the product of the first 2 is 52 more than the third one. Well, this is the third one, and then this is 52 more than the third one. So 52 more than the third one is equal to the product of the first 2. And then we get this. And at that point, it's done being a story, and we just have a quadratic. So I distributed the x. Then I moved everything to this side, and I got it equal to 0. And at that point, you could complete the square. You could use the quadratic formula, or we could factor to solve. In this case, factoring to solve is the easiest. We get this. We get x equals -8. We get x equals 7. -8 is silly because it's not odd, and we get x equals 7. So if x equals 7, well, then the next one is 9, and the next one is 11, and we get these solutions, and you can check your answer. Does the product of the first 2, 7 times 9, which is 63, is it 52 more than the third one? Sure. 63 is 52 more than 11. Okay, next one. The sum of the squares, so the sum means add, and we know how to square things, of 2 consecutive even numbers. Okay, so first thing, we got to establish what these even numbers are. 2 consecutive even numbers can be expressed as x, that's the first one, and then x plus 2 is the second one. Now we got to do what the sentence says. The sum, which means add, of the squares of the 2 consecutive even numbers. So this is the first even number squared plus the second number squared. So this is the sum of 2 consecutive even numbers is 452. So at this point, we just have to be careful that we make sure we FOIL this, which means we distribute x plus 2 times x plus 2 is x squared plus 4x plus 4, right? We have to FOIL. We get this, and then I factored out of 2, and then I thought about factors of 224 that have a difference of 2, and I got 16 and 4. And in this case, when you check your answers, both of those are consecutive even numbers, and both of them, the sum of their squares, are 452. You can just check, take 14 squared plus 16 squared, and they're equal to 452. All right, next one. Find the length and the width of a rectangle whose length is 4 longer than its width. Okay, so let's just call x the width, and maybe I could have drawn the rectangle. Thus, the length is x plus 4. Now look, that's what this says. The length is 4 longer than the width. So if we call the width x, the length is 4 plus x. Okay, so then I have my length and my width, and I know the area is 60. So then I just set 60 equal to the length times the width. We know how to find the area of a rectangle. And at that point, then it becomes a quadratic. I distributed the x, I subtracted the 60 over, I factored it, and I solved. This x equals 10 is silly. You can't have a negative length. And so then I use x equals 6. And if x equals 6, then I come back up here and I say, well, if x is 6, then the length is 10. And then boom, I can check my answer. Is this a rectangle that's got an area of 60? Yes. Is this a rectangle whose length is 4 bigger than the width? Yes. 10 is 4 bigger than 6. All right, let's scroll down. All right. The length of each side of a square is increased by 6. Okay. And then the area is multiplied by 16. Okay. Find the length of one side of the original square. So this is the first thing you should do. Draw this picture. Just draw a picture that has x as the length of the original square. Thus, the original square's area is x squared. X times x. Okay, so now let's go back to the sentence. If I increase the length by 6, that's what that is. So my new length is x plus 6. The area is 16 times bigger than the original. Well, so if x squared is the original area, the new area is 16 times that. So 16a, or you could have just put in 16x squared. So 16x squared equals x plus 6 squared. So it's telling us that if we increase x by 6, we increase the area by 16 times. And so we get this equation. Once you get this, you can solve however you want. Quadratic formula, looks like I ended up factoring it. I guess you could have completed the square, which would be really messy. And then you get an x value, and you get 2 of them. The negative one doesn't make any sense, and you get an x value of 2. That tells you the original square's length. And now we can check. If the original square was 2 by 2, it must have an area of 4. If I increase the side length by 6, then I have an area that's 8 by 8, which is 64. And then look what happened to the area. The area is 16 times bigger. So increasing the side length from 2 to 8 made the area go from 4 to 64. 16 times. So it works. And again, draw your picture and then do what the sentence says. You're changing a sentence into an algebraic equation. All right, this is one that you may not have seen before, but this is one that Algebra 2 people love. And I think we said in class that we could do this with, like, here's your pool, and then here's a bigger border around your pool of concrete. Well, in this case, you got some picture. Here's your picture. Maybe I can't get that anymore. Okay, here's your original picture. It's 60 by 80. And what you're going to do is you're going to take a mat and go around that thing. Well, it's going to be bigger than it. Okay? And so it's going to be bigger by so much. You don't know how much. Okay, that's what x is. X is this border width. And so if you think about it, your original is 60 by 80, but now the new width is 80 plus 2x. So you got a little border here and a little border here. And then your length is 60. Well, your new length is 60 plus 2x, because you got x up here and x down here. So you want your new thing to have an area of 10,000. So there we go, length times width. Your new width, your new length, multiply together equals the new area. And then I actually just took this and I graphed it and I solved. Okay? That's how big the border should be. That's how big the map border should be, such that your overall photo now has an area of 10,000. Okay, and this one's actually probably the easiest one, because you're just given the equation. Okay, so if you just graph this equation on your calculator, you're going to get a quadratic that looks like this, and you can answer all these questions. You can find the vertex, right, using your calculator or just the quadratic formula, a negative b over 2a, all sorts of stuff. You can find the maximum height. You can find the time it's at a maximum height. You can find the x-intercept, which is how long the object is in the air, because at the x-intercept is when it hits the ground. You can find when an object is at exact height, because you can graph this guy. Right? You can graph the original function, and you can graph y equals 65, and then you can find the intersection. This question is identical to the questions we did in the graphing calculator unit, where we were showing you how to find maxes, y-intercepts, x-intercepts, and intersections of curves. So the actual more difficult one is the physics one, but it's actually easier because the equation is given to you. All these other ones are more difficult because you got to come up with the equation first and then solve. Okay? Again, watch this video again. Think about how I came up with the variables to start, how I wrote the equation. But certainly, once you get the equation, solving it from here to here is a total review of the old stuff. Solving a quadratic can be done by using the quadratic formula, by factoring, or by completing the square.